Hello, I am Krishnadas Ji from College of Engineering, Adobe. My topic of discussion is graph coloring. Graph coloring has wide range of applications and mathematical modeling. Through this presentation, let me explain what is graph coloring, how we color a graph, what are the applications. What is graph coloring? It is an assignment of colors to the vertices of a graph such that adjacent vertices always have different colors. This is an example of a 4 colorable graph. It's a graph with 5 vertices. The colors are assigned such that adjacent vertices always have different colors. Now some terms in vertex coloring. Connected graph, complete graph, tree, bipartite graph, linear graph, null graph. Another term is chromatic number, then chromatic polynomial. These are different types of graphs. Connected graph. A graph is said to be connected. Any two vertices are connected by a path. A path is a sequence of vertices and edges. This is an example of a connected graph. Now, complete graph. A graph is said to be a complete graph if any two vertices are joined by an edge. This is an example of a complete graph. Now, tree. Tree is a connected graph without circuits. Circuit is referred as a closed path. So, without closed path, a graph which is connected and without closed path is called a tree. Now, linear graph. Linear graph is a connected graph with two pendant vertices. It is an example of a linear graph. Now, chromatic number. It is the minimum number of colors required to color a graph. For this graph, the minimum number of colors used to color the graph is 2. So, its chromatic number is 2. This is a graph with chromatic number 3. Chromatic polynomial. It is the number of ways of coloring a graph with n vertices using k of your colors. The number of ways of coloring a graph, G, with n vertices using k of your colors. It is called the chromatic polynomial. For this a complete graph with 3 vertices, A, B, C. And here the chromatic polynomial is, these are the options. That is, we color C1 to the vertex A, C2 to the vertex B, and C3 to the vertex C. There is one combination. C1, C2, C3 to the vertices A, B, C. Then C1, C3, C2, then C2, C3, C1, C2, C1, C3, then C3, C1, C2, C3, C2, C1. So, totally 6 ways are possible. So, the chromatic polynomial for this is given by, if we use k colors, it is given by the formula k into k minus 1 into k minus 2. Then these are some standard graphs and their chromatic number, the formula for chromatic number and chromatic polynomial. For a complete graph with n vertices, the chromatic number is n and chromatic polynomial is with k colors is k into k minus 1 into k minus 2 into etc. k minus n minus 1. Linear graph, chromatic number is 2 and chromatic polynomial is k into k minus 1 raised to n minus 1. Empty graph, chromatic number is 1, chromatic polynomial is k power n. Now, some results. Chromatic number of a graph G is the minimum value of k for which the chromatic polynomial is non-zero. For a graph G, we have a property that for an edge E, chromatic polynomial of the graph G is equal to chromatic polynomial of G1 minus chromatic polynomial of G2, where G1 is a graph obtained from G by deleting the edge E, and G2 is a graph obtained from G by merging the endpoints of E. This is a way of applying that result. Here G is a graph with the specific edge E. Then G1 is this graph. This obtained from G by simply removing the edge E. And this is G2. In G2 what happening is we simply merging the endpoints of E together and transformed as a single vertex. So one, that merging one, this is G2. Similarly, we can subsequently applying this result as G1 by taking this as this edge as E, then this is G11 and this is G12. G12. This is G12. Okay. Now, how we color a graph? This is an algorithm for graph coloring. First step is arrange the vertices in the order of decreasing degrees. Second step, assign the color C1 to the first vertex, and then in the sequential order, assign C1 to each vertex which is not adjacent to the previous vertex which was assigned to color C1. Thirdly, repeat step 2 with the second color C2 and subsequence of non-colored vertices. Repeat the process with colors C3, C4 until all vertices are colored. So this is an algorithm for color a graph. Now this is a situation how we apply that algorithm to color a graph. So this is a picture of the graph, and this is the order of the graph with the decreasing degrees V2, V5, V3, V4, V1. Now how is we will see that how we color the graph. This is a graph which is 4 colorable. Now, why coloring? Mapping problems, scheduling problems, timetable formation as used as a part of coloring. This is a problem to schedule 6 1-hour lectures, L1, L2, L3, L4, L5, L6. Among the audience, there are people who wish to attend both L1 and L2, L1 and L4, L1 and L6, L2 and L6, L3 and L5, L4, L5, etc. How many hours are necessary in order that the lectures can be given without clashes? So what we do is we represent that model as a graph where vertices correspond to the lectures and edges represent clashes. Then we have to determine a proper coloring, and this is the coloring. V1 colors 1, V5 color 1, V6, V4, V3 with color 2, and V2 with color 3. Now we assign the hours, hour 1 to a particular color. So L1 and L5. Then hour 2 is another color that corresponding to the lectures, L3, L4, L6, and hour 3 is L2. These are some suggested readings in connection with graph coloring.